Dear students, welcome to our science episode. Today we are going to continue discussing wave motion. We already knew that waves are classified according to the ability to propagate and transfer energy into mechanical or electromagnetic waves. Mechanical waves. Waves that need a materialistic medium to propagate. They do not travel in vacuum or space. Examples: transverse water waves and longitudinal sound waves. Electromagnetic waves. These waves can propagate in any materialistic medium and vacuum, this or that. And the velocity of electromagnetic waves is much greater than mechanical waves. It's equal to 3 times 10 to the power 8 meter per second. Examples: transverse light waves and transverse radio waves used in radars. Now, can you explain why sound waves are longitudinal and mechanical waves at the same time? Sound waves need a materialistic medium to propagate in. That's why they are mechanical waves. And they are longitudinal waves because the particles of the medium will vibrate parallel to the direction of waves propagation. Or as we said before, the two lines will be in the same direction. Why we see the lightning before we hear the sound of the thunder, although they happen at the same time? Light waves are considered to be electromagnetic waves, while the sound waves are mechanical waves. Electromagnetic waves' velocity is much greater than mechanical waves. That's why we see the lightning before we hear the thunder sound. We see the sunlight, but we do not hear the solar explosions. Light waves are electromagnetic waves which travel in media and space, while sound waves are mechanical waves which travel in media only. Now choose the correct answer. All of the following waves travel in space except it's sound waves. They are electromagnetic waves used in radars, radio waves. Waves are composed of compressions and rarefactions. Sound waves. Now let's discuss some concepts related to wave motion. Wavelength. It is the distance between two consecutive crests or troughs, or the distance between the centers of two consecutive compressions or rarefactions. Here are two crests, and here are two troughs. This distance between two crests or two troughs is called wavelength. It is represented by the Latin letter lambda, and it is measured in meters. This is transverse waves. In longitudinal waves, it is the distance between two compressions or two rarefactions. Both of them are called wavelength. What will happen if the distance between two consecutive crests is doubled? So the length of the wave will be doubled too. And what will happen if the distance between two consecutive compressions decreases to the half? So the length of the wave will decrease to the half. This means that the wavelength equals total length of the wave divided by the number of waves. And the wavelength equals the distance covered by the wave divided by the number of waves. You can notice also that wavelength is equal to 2 times the distance between compression and rarefaction. Wavelength equal 2 times the distance between crest and trough. Now calculate the wavelength for a transverse wave. The distance between its crest and trough equal 5 meters. From the previous slide, we know that the wavelength equal 2 times distance between crest and trough. So equals 2 times 5 equal 10 meters. Calculate the wavelength for a longitudinal wave. The distance between the center of compression and the third center of rarefaction equal 15 meters. This is tricky because he gives you the distance between the center of a compression and the third center of rarefaction, not the following center of rarefaction, the third one. So we have to say that the number of waves equal 2. Wavelength equal the distance covered by the wave divided by the number of waves. Wavelength equal 15 meters divided by 2 equals 7.5 meters. Number 2, we are going to discuss the amplitude. And the amplitude, as we said before, it is the maximum displacement achieved by the particles of the medium away from their points of rest, and it is measured in meter. Look at this diagram. This is the amplitude. The distance, the maximum distance, the wave traveled away from its point of rest. So it could be the distance from the horizontal line to the crest or the distance between this horizontal line to the trough. Again, we can calculate it by dividing the vertical distance between the crest and the trough divided by 2. Or the vertical distance between crest and trough equal 2 times the amplitude. Now, what is meant by the amplitude of a mechanical wave is equal to 2 centimeters? It means that the maximum displacement achieved by the particles of the medium away from their point of rest is equal to 2 centimeters, or in another word, 0.02 meters. Look at the following graph and calculate the amplitude and the wavelength. As we know, the amplitude equals the vertical distance between the crest and the trough divided by 2. The distance here is 2 meters divided by 2, so the amplitude is 1 meter. The wavelength equals the distance covered by the wave divided by the number of waves. The distance is 16 meters. The number of waves, let's count it together. This is 1, 2, 3, and 4. So 16 divided by 4, number of waves, it will give us 4 meters. Number 3, the wave velocity. It is the velocity of the transfer of energy carried by the wave. It is the distance covered by the wave in 1 second. And it is measured in meter per second. Now, what is meant by the velocity of a wave is 300 meters per second? It means that the wave covers 300 meters in 1 second. What is meant by the distance covered by a sound wave in water equal 9 times 10 to the power 4 meters in a minute? As we know that velocity equal distance over time, so velocity equal 9 times 10 to the power 4 divided by 60, which is equal to 1,500 meters per second. Now, can you calculate the velocity of a wave that covers 40 meters in 4 seconds? Again, velocity equal distance over time, so the velocity equals 40 divided by 4, which is equal to 10 meters per second. Now let's discuss frequency. And as we said before, frequency is the number of complete waves in 1 second, and it is measured in hertz. The equation is frequency equal number of waves divided by time in seconds. Periodic time. It is the time for one complete wave. It is measured in seconds, and it's equal to the time in seconds divided by the number of waves. Remember that frequency times periodic time equal 1. If you have the frequency, you can get the periodic time, and if you have the periodic time, you can calculate the frequency. Now calculate the periodic time for a microwave whose frequency is 25 times 10 to the power 8 hertz. Periodic time equal 1 divided by frequency, so it's equal to 1 divided by 25 multiplied by 10 to the power 8, which is equal to 4 times 10 to the power negative 10 seconds. Now it's time for questions. Complete the following sentences. If the wavelength of a wave is 2 meters, the distance between the first center of compression and the third center of rarefaction is 4 meters. If the horizontal distance between the second crest and the fourth crest is 6 centimeters, the wavelength is 3 centimeters. The wavelength of a longitudinal wave is the distance between two consecutive compressions or two consecutive rarefactions. In the following graph, find the wavelength, the frequency, the periodic time, and the amplitude. As we all know, wavelength equals distance covered by the waves divided by the number of waves. Wavelength will be equal to 4 divided by 2, which is equal to 2 meters. This is the distance covered by the waves, which is 4, and the number of waves. Let's count together. This is 1 and this is 2. So 4 divided by 2 equal 2 meters. Periodic time equal time of one complete wave, which is 0.2 times 2. This is the time of one complete wave. So 0.2 times 2 equal 0.4 seconds. Frequency equal 1 divided by periodic time, which is 1 divided by 0.4 equal 2.5 hertz. Amplitude is the maximum displacement of the wave away from their points of rest. The amplitude is 1 meter. Thank you. Dear students, thank you for watching. See you later in other science episodes.